The title of my paper is Choice Screen Auctions. And before jumping into the substance of the talk, I just want to make a caveat that I'm going to be talking about some shortcomings of the design of these auctions, but that should not be taken as criticism of Google or the European Commission. If anything, they should be praised for trying new regulatory tools in fairly complex environments. And the specific environment is indeed quite common. The issue here is that we have a platform A, and there is a product owned by the same firm that owns the platform A, and there is a competing product, product B, that is independent. And the question is, how can we ensure that products A and B compete on equal footing and are not advantaged by the tying between platform A and product A? This is a very common problem, long studied in antitrust, and it is particularly common in the tech world. You can probably come up with dozens of examples very quickly. In fact, it's hard to find examples with platforms where this doesn't show up. And we have very few regulatory tools to help us elegantly manage this issue. One of the tools we have is breaking companies apart or prohibiting them from competing on their own platform. But obviously, these things are very heavy-handed, and we need new solutions. And this is where this idea of choice screens and choice screen auctions comes in. So let me first talk about choice screens. So the idea of a choice screen goes back to 1999 and was initially proposed by Microsoft as a potential remedy in the Internet Explorer Microsoft Windows tying case. And it was proposed by Microsoft as a potential remedy, not adopted at the time in the United States, but it was adopted in Europe for a 5-year period from 2010 to 2014 as an agreement between Microsoft and the European Commission. And the idea is that when you install a new copy of Windows, instead of having Internet Explorer pre-installed, you would get a choice screen in front of you where you have a choice of multiple browsers, one of which is Internet Explorer, but you also have several others. And then that allows these browsers to compete on equal grounds. And just to give you a sense of magnitudes, Microsoft accidentally removed one of the versions of Windows, one of the versions of the choice screens on Windows from May 2011 to July 2012, and that affected 15 million users. They admitted their error, ended up paying a fine of more than €500 million, more than $500 million. So it's important. Everyone views this as very important. Now, fast forward a few years, and essentially an identical problem happened on the Android platform, operated, of course, by Google, where the European Commission found Google guilty of illegally tying its Chrome browser and the Google search app to the Android platform. They charged a $5 billion fine. And then as part of the subsequent settlement in 2018, Google agreed to displace choice screens for alternative search engines and browsers to Android users in Europe starting in 2019. Now, the innovation introduced by Google in August of 2019 to take place starting 2020 was the idea to auction off slots on these choice screen, right? Because there is a very natural question, who are the lucky search engines that get displayed and can be chosen by the users. And Google said, look, we're going to let the market decide. We're going to run these auctions on a quarterly basis, separately in each of 31 countries in Europe. And as whoever is willing to pay the most is going to be displayed. And of course, Google is going to be displayed as one of the auctions. And that's one of the justifications. They said, look, we make big investments in the Android platforms. That revenues from this auction will help us to continue to improve that platform. And here are a couple of screenshots from Google's webpage explaining how this auction works and explaining why they do things the way they do. So first, from the Q&A section of the website, why does Google use an auction to determine the search providers that appear in the choice screen? Their answer, an auction is a fair and objective method to determine who should be shown. It allows search providers, and here I want to slow down because this is important, to decide, let me change this to a highlighter, to decide what value they place on appearing on the choice screen and to bid accordingly. Okay, sounds reasonable. Now, here are the specific rules of the auction, the choice screen auction. Google will use a fourth price auction to select the other general search providers that appear in the choice screen. Google will conduct auction on a per country basis. etc. In each country auction, search providers will state the price, and again, I'm going to slow down, state the price that they're willing to pay each time a user selects them from the choice screen in the given country. The 3 highest bidders will appear in the choice screen for that country. The provider that is selected by the user will pay the amount of the 4th highest bid. All right, and then the winners are going to be ordered randomly. So once you're a winner, it doesn't matter whether you're a top bidder or a second highest bidder. And in fact, this is an incentive compatible auction, right? So I'm sure all of you are familiar with the idea of the incentive compatibility of the second price auction. In a single unit case, it's the same thing here. We have three highest bidders win, pay the bid of the fourth highest bidder. So it is incentive compatible to bid your true value. However, where things get more interesting is this distinction, the 2 things that I highlighted. In one place, they say, you decide how much you value appearing in the choice screen. And in the other place where the actual rules of the auction show up, you bid on actually being chosen by the user. And at first, this looks like just a statistical distinction. You're like, look, you can multiply something by something, and they will be equivalent. And it turns out this is not at all the case. The difference is very important. And let me explain this difference with one simple example. And in fact, this is the most important slide of the paper. It kind of captures the essence of the issue. So suppose there's only one slot available in addition to Google. So Google is always shown as the option, and then we're auctioning off one other slot to be shown next to them on the choice screen. And there are 2 competing search engines, search engine X and search engine Y. And search engine X is kind of greedy. They try to monetize aggressively. They value each user at $20. All right. And search engine Y is not as greedy. Maybe they use revenues to plant trees, or maybe they're very privacy conscious, or maybe they show fewer ads. So they value each user only at $10. Okay. However, because search engine X is greedy, very few users would install it if it was shown on the choice screen. Only 50 users would actually install it. Whereas search engine Y, because they're more user-friendly, don't try to monetize as aggressively, a lot more users would install them. Let's say 5,000 users would install them if they were shown. And by the way, if you think that these orders of magnitude differences are too dramatic, you will see that they're not. It's actually the kinds of differences we may see. So let's think about how each of the 2 different auctions would play out. If you conduct the auction on a per appearance basis, how much do these search engines value being shown on the screen? Well, search engine X values being shown on the screen at $20 times 50. So they would be willing to pay $1,000 to be shown on the choice screen. Whereas search engine Y would be willing to pay $50,000 to be shown on the choice screen. So if the auction was conducted on the per appearance basis, search engine Y would win and 5,000 users would install it. However, the way the auction is actually conducted on a per install basis, search engine X would bid $20 for each install. Search engine Y would bid only $10 for each install. And so then search engine X would win and only 50 users would install it. So the key point of this example is that this difference between per appearance and per install is not just a cosmetic difference, but in fact a fundamentally important characteristic of these auctions. All right, so let me now show you how this plays out in a model. So I have a very basic model to illustrate this difference. For simplicity, I'm going to assume that there's only one slot on the screen in addition to the platform's own search engine. There are n bidders indexed by I. Each bidder has 2 characteristics. So one, a deviation from a typical kind of model you will see in auction theory is that bidder types are 2-dimensional. One dimension is popularity. How likely are you to be chosen if you're shown on the screen? The other characteristic is RI, how much revenue you would get from each user. And for simplicity, all these variables for all these bidders are going to be uniformly distributed between 0 and 1 independently. And the platform, here is another key distinction from standard models in auction theory. The platform actually values each user at pi greater than 1. So their most preferred outcome is to not have the user choose one of these alternative options and instead choose the default. So this is the incentives of the platform are the seller are quite different from typically what you see in auction theory. Now, in the per appearance auction, each bidder submits a bid. As I said, everything here is incentive compatible. There is no problem. So the optimal bid for each bidder is just to bid the product of the probability of being chosen if you're shown times your value for each user, Ri times Qi. And in the per install auction, you just bid your revenue per user Ri. Notice that in the per install auction, the popularity, how popular the search engine is, never enters into the bidding decision or the auction outcome or into anything at all, right? Everything is driven just by RIs. So here are the results. For simplicity, I'm going to show them for n equal to 2. In the per install auction, the expected popularity of the winner is just 1/2. It's just because it's uncorrelated with the outcomes of the auction, and it's uniformly distributed from 0 to 1. So the expected popularity in 1/2. In the per appearance auction, because bidders are ranked by the product of their popularity times their revenue per user, the expected popularity of the winner is strictly greater than 1/2. So more popular search engines would be winning under the per appearance auction rather than the per install. However, things are reversed when you look at the payoff for the seller. For the seller, the expected payoff is higher for the per install auction than under the per appearance one. And an important component of that is the fact that when a user does not choose the winner, they default to the platform's own search engine, and that gives the platform the payoff of pi. All right, now the results when n go to infinity only get stronger. The expected popularity of the winner of the per install auction remains at 1/2, whereas the expected popularity of the winner of the per appearance auction converges all the way to 1, right? If you have a lot of draws from two uniform distributions, the winner is going to be the search engine that gets a high draw from both of those. And when you look at the expected payoffs of the platform, they diverge even more. The expected payoff is higher under the per install auction than under the per appearance auction. So there's a divergence between, if we want a more popular search engine to be winning, per appearance auctions will be better. But if you look at the payoff of the platform, it goes the other way around. Now, one extension that I look at in the paper is I endogenize Qi and Ri, right? So a platform may actually have some control. They may say, look, we're going to be more aggressive with showing ads that will make us less popular, or vice versa. We can do some things like give money to plant trees. There are search engines like that will lower our Ri, but may increase our Qi. And the way I model this, again, is very straightforward. I assume that each bidder has technological type Ti drawn IID from the uniform distribution, and then they can allocate before the auction some fraction of this type to revenue, and then the remainder is going to be their popularity. Okay, so if you choose a high revenue, your popularity is going to be low, and vice versa. And then after that, everything is exactly the same. Okay, you submit your bid, and again, conditional on your choice of Ri and Qi, auctions are incentive compatible. So the results are, in the per appearance auction, it turns out that no matter how many bidders you have, it's optimal for the bidder to just split their type in the middle, allocate half of it to popularity, allocate the other half to revenue. And, the exact value half, of course, is driven by the specific functional form assumptions, but the fact that how they split this doesn't depend on how competitive the auctions are is actually more fundamental. By contrast, in the per install auction, the higher the n, the less you will allocate to popularity and the more you will allocate to revenue. And it's not surprising because the competition is on revenue per user in the per install auction. So you have to put a lot of weight on that in order to have a chance to win it. And in fact, as the number of bidders goes to infinity, the popularity of the winner converges all the way to 0. All right. So let me now show you some empirical evidence from these auctions. So as I said, there are 4 batches of auctions in 2020, 31 auctions because there are 31 different countries in which these auctions are run on the per install basis. And the outcomes, by the way, are all publicly available, right? So I took this data from Google's own webpage. Here is the link. And here is a table summarizing these results. It's probably hard to read. It's in the paper. Countries are sorted by popularity from the most populous to the least populous. Search engines are sorted by the average population they want. I explain this in a moment, from left to right. And what you have in each cell, because we had 4 auctions in 2020, each search engine had 4 chances to win in each of the countries. So, for example, if you look at, let's say, Bing in Germany, right? So they won in periods 3 and 4, and they didn't win in periods 1 and 2. And so what you can see just by eyeballing this is that info.com, which I'm sure most of you have never heard of, won a slot in every single auction in every single country in every single period. So on average, the population of the countries in which they won is just the sum of the population of those countries, about 500 million people. The second biggest was Privacy Wall. They won a population of about 370 million. And then more popular search engines like Ecosia, which I'll talk about in a moment, only won kind of in one country a couple of times. And here, I weight these observations by population. If you care more about, another alternative way to do statistics is just to count numbers, count each country as a single observation without using these weights. The results remain virtually the same. And here I'm summarizing these results. The observations about the qualities and the popularity of info.com and Privacy Wall are not anecdotal. You can actually go in Play Store and see how many times they were total installed. And we're talking about sort of tens of thousands, which is sort of negligible compared to some bigger search engines like DuckDuckGo or Bing or Ecosia that have millions and more than 10, some of them have more than 10 million installs. So much less popular search engines with much lower ratings, much fewer reviews end up winning. So conclusions, this is a new regulatory tool. So kudos to Google and European Commission to trying new solutions that is potentially applicable in other important settings, but needs to be fixed. And it's important to keep in mind that the objectives of the mechanism design are diverse from those of the auctioneer. Now, the paper ends here, but time and policy impact sometimes move faster than publication process. So this presentation has an epilogue that the paper currently does not. And just 2 weeks ago, there was an announcement from Google that following further feedback from the European Commission, we're now making some final changes to the choice screen, including making participation free for eligible search providers. We will also be increasing the number of search providers shown on the screen. These changes will come into effect from September this year on Android devices. So this flaw that I described turned out to be